Welcome back to this video series on geometry. Today we're going to be talking about Pythagorean theorem. So the Pythagorean theorem applies to right triangles. And remember, the definition of a right triangle is that there is one 90-degree angle. In terms of naming the sides, the side length opposite this right angle is called the hypotenuse. And then both of these other two sides are called legs. These legs do not have to have the same length. Sometimes they do, but in most cases they do not have the same length. So in terms of the length of each one of these sides, we're going to say that A and B are the two legs, and then C is the hypotenuse. And these are side lengths, so they're going to be numbers. Now, Pythagorean theorem is actually very simple. It is just A squared plus B squared equals C squared. And using this equation, we can solve for any of the sides, given that we already have two. So, for example, we have a triangle here, and the side lengths are 3 and 4. What is the side length C? Well, we can see that A squared plus B squared equals C squared. In this case, A equals 3, B equals 4, and left with C is unknown. So we'll plug that in. 3 squared plus, and then B is 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals C squared. And then we square root both sides. And then we'll say that C is equal to the square root of 25, which is just 5. So in this case, C equals 5. And this brings us to another topic for today, Pythagorean triples. So a Pythagorean triple, I'm going to write that out here, is basically just any triangle that has whole numbers for the side lengths, A, B, and C. So A, B, C. What we just did is an example of a Pythagorean triple, and it is the smallest one that we know of, where it has side lengths of 3, 4, and 5. Another really common one is side lengths of 5, 12, and 13, where the square root of, or the 5 squared is 25, plus 12 squared is 144, and that equals 169, and the square root of 169 is 13. So 3, 4, 5, 5, 12, 13, and then two others that are slightly less common but still pretty fairly used are 7, 24, 25, where 7 squared plus 24 squared equals 25 squared, and then 8, 15, and 17. And for each one of these Pythagorean triples, we're talking about ratios here. So let's take the 3, 4, 5 example. 3, 4, 5 is a Pythagorean triple, but if we multiply all of these by 2, and we get 6, 8, 10, that is also a Pythagorean triple. Any whole number multiplier of this Pythagorean triple is also Pythagorean triple. So let's do another couple of quick examples. We have a triangle here where we have side length of 3 and 6. What is the side length C? Well, we can go back to our equation. A squared plus B squared equals C squared. So 3 squared plus 6 squared equals C squared. In this case, we have 9 plus 36 equals C squared. So C squared equals 45. C equals the square root of 45, and that is not a whole number, but we can round that off to 6.7. So in this case, 3, 6, and 6.7. Okay, we'll do one more example here. So in this case, we are given a triangle that has a hypotenuse of 13. One of the side lengths is 4, and we're asked to find out what this other leg is. So back to the equation, A squared plus B squared equals C squared. In this case, we're not given both of the legs. We're given one of the legs is 4, and the other leg is unknown. But we are given the hypotenuse, so we can plug those values in, and we're given that 4 squared plus b squared equals 13 squared. So 16 plus b squared equals 169. We can subtract 16 from both sides, and we get that b squared equals 153. We'll square root both of those. B is equal to the square root of 153. And this is not an easy answer, but if you plug that into your calculator, you get something about 12.36. So B equals 12.36. And this can be used for any right triangle. As long as you know two of the side lengths, you can use Pythagorean theorem to get the third side length. The two side lengths next to this right angle are called legs, and the side opposite the right angle is called the hypotenuse.